Hey, welcome to this lesson on multiplying and dividing rational expressions. How do we multiply and divide rational expressions? Well, we're going to try to apply the same process of multiplying fractions and multiplying polynomials, and we're going to put them together onto one problem in order to multiply rational expressions. And then we're also going to do the same process for dividing fractions. When you do, you may have heard of same change flip or keep change flip or keep change opposite. I don't know what you may have learned in the past, but that's a good acronym or saying to get you to remember what to do when you divide fractions. So we're going to use that and apply it to multiplying rational expressions. So when we multiply rational expressions, it's just like multiplying fractions. If I have 2/4 times 3/6, I'm going to multiply across the numerator, so 2 times 3, and then multiply across the denominator, which is 4 times 6. And that would give me 6 out of 24, which would give me 1/4. Now, what's important to try to realize with multiplying polynomials is that it's important to factor everything first, because you don't want to multiplying polynomials. I think we can all agree takes a very long time to multiply trinomials and binomials, and once you get up to degrees of like 5, then you're multiplying all these steps. And so it's important to make sure that you simplify everything first into their factors. So if I had 2/4 times 3/6, I could simplify that into 2/2 times 2, or sorry, factor that, times 3/3 times 2. Now when I multiply, I can just keep the factors the same. Just keep it broken up into factors. And so if I divide out common factors, I'll see that I'm left with 1 in the numerator and 2 times 2 in the denominator, which gives me 1/4. So we're going to apply that to polynomials now. So let's factor x squared minus x plus 12. What multiplies to 12 and subtracts to negative 8x? That's going to be negative 2 and negative 6. So x plus a negative 2, which is x minus 2, and x plus a negative 6. What can we do to factor 4x plus 16? Looks like both of those terms have a GCF of 4, so I'm going to factor out a 4, and I'm left with x plus 4 on the excuse me, on the numerator. Now, let's do the denominator, x squared minus 16. That's a difference of squares. The perfect squares are x, that's the perfect square of, that's going to go on the right, or on the left, sorry. That's the perfect square, the square root of x squared. 16, the square root of 16 is 4. So 16 is a perfect square of 4, and it's the difference, so our rule tells us we can do x plus 4 and x minus 4. And then on the right side, we have x minus 2 times x minus 2. What multiplies to 4 and subtracts to, adds to negative 4x, and that's negative 2 and negative 2. All right, so you can see all the terms down here, or all the factors down here, And so before multiplying across or multiplying through, what we can do is, okay, I see that one of these x minus 2's I can cancel out. I hate using the word cancel out, but I think you guys know what that means. It means that we're dividing x minus 2 by one of the x minus 2's over here. X minus 2 divided by x minus 2 is 1. So we can essentially, quote unquote, cancel that out. So x minus 4, I can do the same thing. And so now I can just circle what's left. There are no more common factors between the numerator and the denominator. So my final answer, you don't even have to multiply this out. This is perfectly acceptable. 4 times x minus 6 divided by x minus 4 times x minus 2. That is your final simplified answer. Now, I mentioned this earlier in the video when we were talking about what the lesson was about. What do we do when we divide? So we look back and we try to remember our fraction rules. When we divide something, for example, 2 divided by 2, we use a process that we call same, change, flip. Same, change, flip. And reading from left to right, what that means is the first thing, we're going to keep that the same. That 2, we're going to keep it the same. Okay? The middle part, which is the division sign, we're going to change that to multiplication. Okay? So from division to multiplication. And the 2, we're going to flip that. So really, 2 is 2 over 1. That's the fractional form for the number 2. We're going to change that to 1 over 2. So division is essentially multiplying by the reciprocal. That's the mathy words of what we're doing here. Same, change, flip will probably stick in your head a little easier than multiplying the reciprocal, but just so that you guys have the vocabulary, when you divide, you multiply by the reciprocal of a number. Just like when you subtract a number, you're really adding the opposite of the number. Now, division is multiplying the reciprocal. So when I do 2 times 1/2, I go across numerator. 2 times 2 is 2. 1 times 2 is 2. 2 divided by 2 equals 1. And we all know that 2 divided by 2 is indeed 1. So we're going to apply that same process to multiplying and dividing rational expressions. So, same, change, flip. I'm going to keep this part the same. I did that. I'm going to change this to multiplication. I did that. And now this part I'm going to flip. That means x squared plus 9x plus 14. That goes in the denominator now. And x squared minus 8x plus 15. That goes in the numerator. And from there, you're going to follow the same steps as multiplying rational expressions. So we're going to factor each one. So each of these polynomials is factored. And from there, we're going to find common factors, x plus 2, x plus 2, x minus 3, x minus 3. They'll each divide to 1, and I'm left with x minus 8 times x minus 5 divided by x plus 7 squared. And that's my final answer. So we have one more example here. We are going to keep the first rational expression, change to a multiplication sign, and then flip the second rational expression. Then I need to factor everything, and then find common factors, x plus 2 and x plus 2, x minus 2 and x minus 2, and I'm left with 1 over x plus 3. That's all I have for you today. Make sure you go ahead and try your homework assignment, and if you need any help, please reach out or meet me in the Math Cafe.